tell me about your time at DeepSeek.
So I joined DeepSeek at 2024 at the very beginning. So at that time, they were basically working on these MOE models. And when I joined, they were basically working on the DeepSeek V2, which uses like MLA to reduce KV cache and make the model more efficient. During the time there, I was basically working on expert specialization, which means that we have so many experts in a very large sparse model, but how can we make them really take their own roles? So at my time there, I basically discovered a method that can help us make the models become more specialized and adapted to downstream tasks by training the specialized experts specifically for one specific downstream task. So this not only helps reduce the memory and the compute need when we want to adapt the model to the new domain, but also reduce the other irrelevant experts from being too overfit to a single downstream task. So making the model becoming more specialized while maintaining general capabilities.
Curious what you just said, because it's an architectural change, right, in the model.
Yeah.
Do you think this is where the biggest gains are? Or do you think it's cleaner data, more compute?
Under strict the same data, all the algorithms will perform better than before, than the baseline algorithms. I think both of them are pretty important. If we have good data, the model will improve. If we have better algorithms, the model will also improve. So yeah, I think both of them are necessary.
But basically at this point, I would say it's fair to say that each of the main labs have scraped the entire internet. And maybe Google has more proprietary data from YouTube and Google search and stuff like that. So do you think the biggest differences between the labs will be better algorithms, better architectures? Or what do you think will distinguish these labs? Do you think it'll be something else?
Yeah, so there are actually many points that can distinguish those labs. So some labs has more public data from online that they can use. Some labs has better infra that they can iterate their speed very fast. Some labs actually have more compute, so they can train more models, train larger models. I think DeepSeek really has great infra at the time I was there. So I can feel that whenever I have an idea in the morning, I can implement it in the afternoon. Even at that time, we don't have cloud code, we don't have codecs, we don't have code agents. So their infra is pretty much clean. If you want to add something to it or you want to remove something to it, just do it. And you can do it pretty fast. I think this is their pretty much advantage.
So it's basically a very open culture where just elite people can do whatever they think they should do.
Yeah, it's kind of like a bottom-up structure. It's kind of like if you have an idea and you propose it to your teammates, and then you start working on it. And the boss won't interrupt too much, and they will just make sure that you have enough resources, and the idea can be pushed out. And teams do collaborate a lot because there are someone working in the same field, someone working on cross fields. So if an idea has to be pushed out, for example, I'm working on improving algorithms. I also need those people from infra side to improve the efficiency once the algorithm is implemented. For example, writing more kernels. So that's how team members collaborate if they really want to push something out.
What's one of your most memorable stories from working there?
Real quick, if you have an AI business and want to scale it, make sure to apply to my accelerator. If you qualify, we'll work with you for 6 months straight to help you scale, so that you can either build a massive AI company or go towards an acquisition. Just like I did with Vectel, which I managed to sell for $1.8 million just 14 months after founding. So if you want to build or scale your AI business, click the link below the video and apply now.
It might be a little bit cliche, but sometime when I was there, I really enjoyed chatting with those Chinese drama, with those people there, because I feel they are really from very diverse backgrounds, and some of them are actually from Chinese literature backgrounds. Yeah, so I couldn't imagine that I can just chat with all those technical people on this Chinese literature, Chinese drama that much during lunch. So it was really fun for me.
Interesting. Maybe I'm going to go through all the main AI companies and give me, few sentences on each. Your thoughts, what do you think is their advantage? What do you think they're doing right? So let's start with Anthropic.
I think their coding agent is pretty good. So I think their kind of product choice is also pretty good. For example, they have this kind of coworkers. Their product-wise strategical choice is kind of what I love a lot. Yeah.
Okay, OpenAI.
I have been knowing OpenAI pretty early. I knew OpenAI from my freshman age. I knew Gym, like the OpenAI Gym. So it was a pretty early infra that I think just motivates a lot of RL research at the time of their age. So I just pretty appreciate that because it not only motivates other people's research, but also motivates my homework. So after I got to Berkeley as an exchange student in my third year of my undergrad, I started to heavily read their papers, especially about the VPT paper, like video pre-training, where they start to pre-train this model, AI models, not only in language, such as what BERT and GPT do, but also start to use them for like understanding the world through video pre-training. And I was pretty excited about that because I have always wanted to see a game agent that can really play game throughout the world, and this is what they did. So pretty excited about that. Later is the story that we all know: ChatGPT, GPT-5, and all this stuff.
Let's move to Google DeepMind.
We have a serendipity with the DeepMind's AlphaGo. So I was at my middle school at the time, so I didn't know anything about AI. But I did like watch the AlphaGo's live stream and feel pretty excited about that. And after 9 years, we happened to release our RL agent infra that like later like become like a region, which is some work I think should be one of the first agentic RL infra with large reasoning models that happened like at this time, like region. So it was released exactly at 2025. January like 21st, the 27th. So exactly That's 9 cool. years. Yeah. So nice. Like we celebrated both AlphaGo's 10 years anniversary and the Ridge's 1 year anniversary just like last month. So it's quite interesting.
Okay. Next AI lab, DeepSeek. What do you think is their main advantage?
I think what I thought about their advantage, like still exists and they will exist for a long time. Their super good infra ability, how people work there. And I would say that DeepSeek talent is really an important factor for this company to build up. I think not only for DeepSeek, but for a lot of other companies in Haidian. So specifically, like Haidian is a district in Beijing, and they have Tsinghua University, Peking University, and my alma mater, Renmin University, and a lot of other universities that have very good like those AI education. So I feel really good about my teammates, and I also feel that like all these universities are putting much and much more into AI education. So especially I know that some of them are holding AI competition to high schoolers, very serious competition to high schoolers, so that when they directly get into this college, they will be knowing how to train transformers, how to train agents.
That's crazy. And do you think China does this better than USA?
I don't know how USA do this to high schoolers actually, because I didn't finish my high school here. So, but I know from my Chinese high schoolers students that Chinese is holding something like this.
Yeah, I feel like this is, you know, in the Western side of the world, these changes are super slow, like to the educational system, or you know, like something is happening. It's like, okay, focus 20% time of high schoolers on this, right? Like AI is changing the world. I feel like that would just take forever, and I don't think there's any Western country where that's happening. But you know, in China, it's like you can make these changes a lot faster. Would you agree? It's like almost allocation of the resources of the best talent, like how they're allocated.
I feel US is more interest driven. So if you like it, you can go for it. I think this is nothing bad because this will make those people more motivated to go to this area, and they will still become very top researchers in this field, or like top contributors to this field. But if you put more resource, statistically, you will get more talents. So yeah.
Okay, what do you think about XAI?
I know XAI because some of its members is from SG Lang, and I do love this infra. So they kind of push forward language model inference from singleton to multi-turn, and they did this very fast. I think like it's one of the fastest inference infra that allows this multi-turn agentic training, agentic rollout for RL training. So I think it's quite pretty much close to where we had at region, but they made it pretty much faster. So I think we did this multi-turn RL training at January last year, and they did this at I think February last year. But I think it's kind of like 2 times or 3 times faster than our implementation. So I feel they are like pretty good researchers from SGLang, and I know that SGLang has a lot of people from XAI. So that's all I know about XAI. Yeah.
What about Moonshot AI, creators of Kimi?
I first know Moon is from Moonshot's paper, like Moon is scalable. In that paper, they kind of measured why this optimizer is better than Adam, and use very large scale study to do that. So from this kind of thing slides, I feel that they are this kind of company who raise a lot of literature and kind of AI work, and try to figure out which of them is good, which of them is not, and boldly adapt them to their models. I kind of feel that this strategy is very rare for now, because many people will only follow those who already succeed. But very rare people will follow this who had the potential to succeed, but currently not. So I think they're the very first followers of Moon. And I believe that their team will continue to find all these insightful papers in this field, or even create their own very insightful papers and ideas, and keeping adapted to their models. So that's very good feature to learn from all over and adapt from all over. Yeah.
I think you have unique perspective on the China versus US AI race, right? You've been on both sides, and you can compare it probably better than most people can, who are only from outside. Personally, I haven't really spent significant time in either China or USA, right? So I'm complete outsider, but most people who talk about this are either on the Chinese side or on the USA side. You have unique insight in both. So who would you say is actually winning, and what do you think are the main differences in the AI race? Because for example, China has a lot more energy, right? They're adding a lot more to the grid, and I think this is something that nobody in the West is doing. If you look at some countries like Germany, they're shutting down their nuclear reactors, so they're literally sabotaging themselves. So just give a broad analysis. I don't want you to get into trouble or anything, or go deep into politics.
I can speak more about the talents, because
sure.
Actually I pretty much know what Chinese education system is like. So
well, you start there. The Chinese educational system, what people don't understand about it.
Yeah, sure. So let me do a brief introduction to that. So I think the biggest difference between Chinese education system and a lot of the countries outside is they have a very standardized testing system that keeps nurturing while filtering those talents from their very early stage. So it's kind of like at 6, when you go to primary school, you will be many people will tell you that learning from school is not enough, and you probably need to learn outside the class. For example, you take some mathematical classes, and you take even piano classes. I don't know why the parents feel that taking piano classes will help the people succeed, but the truth is that. So
I also used to take piano classes when I was in elementary, so in Czech Republic,
I think when you kind of go to middle schools, and there will not only be those classes, but also there will be some those Olympia challenges that takes you to become the very top student beside your group. So it's kind of I think I took about 1 or 2 classes per week, but I know that some of the students just take spend their whole weekend to this math classes and physics classes, English classes, to help them get better grades at these competitions.
So basically, kids spend way more of their post-school time preparing, studying, grinding.
Yeah. The key feeling is that this is very high pressure, and it keeps a very competitive system, so that when people are inside, you are pushed to go forward. For example, we do not only have this final exam, 高考, but at each month, our high school will also have this kind of monthly exams. And at the last year of our high school study, each day we will finish at least 2 exams, and each week we will have a complete simulation of Gaokao.
So almost like more gamified, like more, competitive system.
Yeah. And it feels pretty standard. So you can always have those talents that you would like to have. So it's kind of like you design a metric. And under this very competitive and standardized system, you can always filter out someone that like fits into your requirements. Yeah, and as the base of the education system is pretty large, like there's always someone who is very talented. Yeah. I think my high school and my middle school is much better than everywhere else because at least at the first and the second year. So our middle school and high school all have 3 years. At least at the first 2 years, we do not have that much pressure, and we don't need to go to all these classes at weekends. So it's probably much better. And I have joined lots of clubs during my middle school and high school, for example, like Model UN and also like some kind of chess classes. So I kind of feel that my interest and motivation is largely kept like during this middle school and high school training. And I feel that this is why I kind of have much motivation to pursue something when I go to college. Because like some people, when they are getting too much high pressure and they got the kind of driven by the outside system, when the system disappears, they will feel a lack of motivation.
Yeah.
And I kind of feel that I kept this motivation. So yeah.
I think it's a similar transition where like people go from like a work environment, right, to 9 to 5, and then they start their own business, and suddenly they have like no tasks, nobody is watching their schedule, and they have like too much freedom. Yeah. I think it's a similar thing. Okay.
Yeah.
That's interesting. So would you say like the system, which like Western educational versus Chinese, which is better at like getting the best out of the best people?
I think both can have this kind of best outside best people. So I do have a strong belief in that. So I can like demonstrate a little bit. I kind of feel that if you want to be very top, you need a very strong motivation, and you need to be capable to work well under high pressure. So I feel that in China, if you have the motivation and you are already in the system that keeps this high pressure to you, then like you can keep driving through a research line or some kind of motivation pretty fast. And in US, you have motivation and you can allow yourself to be competitive under high pressure. I think you also become pretty best. So I'm not sure about the average or like what specific American high schoolers is like, because I've never chatted with any of them. But I feel that if there is competition, there is stress, because we can just see from these admission rates for Harvard, MIT, and they are all very low. So if you want to keep competitive and through your peers, you must be working pretty hard. So I feel that this is pretty similar in US and like even other countries that have their own educational systems.
And about the energy, do you have any insights there? Because like I think this is another massive difference where China is like deploying a lot more, and every other country is like kind of falling behind in this. Or like, do you think this will not be a bottleneck if we scaling AI? Do you think the bottleneck will be somewhere else in the next 5-10 years?
Yeah. I think the key idea is that whoever creates an agent that can improve themselves at a comparable rate, they will kind of have a very high advantage at this time. And I don't think this will require that much energy from all the fields, because I feel that if you have better data, if you have better algorithms, if you make your agents in this kind of self-improving loop, then it probably can become better, and they will know how to save the energy. Because
so
when you really create a self-improving agent, you are in a different stage.
So you think that is like the big question, who gets there first?
I think so, yeah.
Okay, and if you had to say like how far we are, what's your intuition from recursive self-improvement?
So for myself, I work extensively on self-improving agents, and I feel current agents have very good abilities that are already, I think, pass the line to become self-improvement, like their kind of common sense ability, reasoning ability, and also like alignment with human. Like they know what should be do or what should be done, what should not be done.
So basically, like we are limiting them with like lack of tools, environments, permissions, protocols.
Yeah, the key bottleneck here is context lens. So first is context lens. You probably see the case that someone like, I think like recent news that someone like put kind of coding agents to their working environment and it deleted all their files. So the kind of story is that because the agent has limited context lens, so after working for several steps, it should clean their memory. And when it cleans the memory, they deleted the initial instruction that they cannot delete the like something from their computer. So I think the key bottleneck here is memory. So if agents have near infinite memory that they can really leverage, so first you need to make the model able to contain that much memory. The second is that you need the agent to really utilize this memory, because sometimes agents, even if they have the memory, they don't use that.
Most people just summarize at like 100K, 200K, even if the model allows 1 mil, because it's not effective.
We have a work at our lab, especially in vision language model case. So the model, so the paper is like why VLMs fail at spatial intelligence. It's like when you let a VLM work on this kind of spatial tasks, you give them an image. They didn't even refer to their image in their attention space. So that's a lot of tokens, but they don't see it. So kind of, I feel when the context lens is even more, it will be even harder to retrieve this kind of memory from a very large context. So I feel a key bottleneck is here.
So what's your intuition there? Do you think it's like embedding some sort of vector database into the architecture? Do you think it's, letting the model update its weights in real time? Do you think it's context window of 100 million tokens?
Yeah. So I do have several works going on, so I might not be going too detailed into that, but I think there are just several routes that you can go forward well. So the first is to rethink about memory from human side. Yeah. I've heard about an opinion. I think maybe it's a verified scientific fact that human memory is not KV cache. Human memory is not to retrieve from a large code base. Human memory is kind of a hallucination. So you experience new things.
Yeah, people don't realize this. People don't realize when they recall the memories, they're adding details and it's less and less reliable.
Yeah. It's kind of hallucination. So you do this new experience and you retrieve from your update parameters, but you don't know if it even exists. I think if we really do this, we might have a kind of agent that has very long memory, I think as long as maybe human memory, and even more than that. But this will maybe make them make more mistakes, because the human also hallucinate a lot, and sometimes this will harm them. But maybe we can find a way to control this kind of hallucination and to make it maybe happen at those unimportant details, but not happening at those important stuff. So maybe we can build an agent that keeps much more memory than that. And another kind of route I feel is that we offload much thing and only retrieve them when available. So this is what you mentioned about, like we have kind of a vector base and we have this cache and we retrieve from them when necessary. I think this is also much doable, but I kind of feel that both this way or the way that I mentioned earlier, like about storing in parameters, all pretty much need pretty well memory benchmarks, because as far as I know, current benchmarks focus a lot on actually this long context understanding. But if you really want to find this realistic memory benchmark, it's very hard. So if any of your readers or audiences know this kind of benchmarks, please suggest to me in the in the comment box. Yeah. So go ahead.
Well, I was about to say that it's interesting that, like, as you said that, I realized there's not that many popular benchmarks about this, right? Like most benchmarks, like coding performance, scientific, GPQA, ERIC AGI. There's not many benchmarks that properly test it. Like, there's needle in a haystack, but that's like in most situations, not how it works. Like it's not like some random fact. In fact, it's kind of opposite of human memory. It's like you go through a month of your life and then like, what car did you see that Tuesday? It's like, I don't know, what color was that car? And it's like the model would nail that, right? So that's like kind of useless. We need different benchmarks for memory, right? Like we need something
Yeah,
like
yeah,
go ahead.
yeah. I mean, it is pretty hard, and I see what you mean. We need real new benchmarks. Like we really have a simulated user, and it keeps chatting with the agent. And when it wants to record something, it just asks the agent, "So what did I do?" And the agent can retrieve from all of its context windows. And I have some friends doing on this field, and they just feel like the most difficult part of this kind of simulated user for memory benchmark is not only like reproducibility, because each time the user might generate something new, and this will make your benchmark not that much stable. But also is because they feel that all these language model simulated user are just too smart, and they are not that much like real users. For example, if I were to ask GPT for several kind of things, I might be very vague at start. Like I just ask, so what is that? What is that? And GPT replies to me, and I was just recall, okay, what I exactly want to say is something, and I keep polishing my query at the time. But current language model simulated users, they just very clearly state all things about their statement at the very first stage, and the agent to be tested is just feel very clear about that, and they do not have any stress on how to keep memory, keep understanding the vague user query, and keep making the conversation helpful. So at this time, we might still need real human data for this kind of memory evaluation, and I feel this is why only like those large companies are doing this right now.
So you're bullish on companies like Mercor, Search AI, who are like generating these labelers. You think it's very much needed?
I'm not sure whether labelers are more important or real users are more important, because I kind of feel that in real users, you don't not only have this kind of crowdsource workers, but you also have those people who are actually working on very diverse domains. Like you really have people, working on math, working on medical, working on law, like all these fields. You do have this kind of people. So you can help your model improve in all these domains.
So basically, it's almost a trap having these labelers. Like, because you give them instruction, then you don't get sparse data. You just, it's too specialized, and it doesn't, like you need users that are power users and beginners. You need people who are like just doing some task or doing like scientific research. Like, is that fair to say? It's like real users, the closer to the use case that you want, that's how you should be getting the data, basically.
Yeah.
Okay. And on the topic of recursive self-improvement, like would you say, apart from memory, like you said a pretty big statement, you think like the current models are basically there, that they are basically capable of this. So like what else is missing?
So if I were to say, I feel that besides memory, the other thing is whether they can really improve from memory. So for example, like you have all this like Google search. So they are kind of a search system that they really have good memory. So when someone posts on the internet, they can like retrieve whenever there's a query. But you have very good memory, but you don't know how to use Google search to create an agent that knows everything in the internet. So a kind of thought on this is like, when we have an agent that have infinite memory, can it really learn from these failures? So one of our labs work on this field is like when the agent fails at start, we just prompt it to try again and do this task again. And
you had a paper on that, right?
Yeah. So we wrote a paper on that, and I think there's also a very, if I were to say it's very old, but actually I think it's 3 years ago, like a reflection. So published by people from Princeton, that they also let the model to try again if they fail at start. And we kind of feel that current RL even make this worse. So if a model can like finish the task early, it's okay. But if fails at start and we prompt it to try again, it will insist their current failures. Like it will think again and produce a very long chain of thought. And after that, it will say, okay, I still insist to my previous answer, but not like generating something new that really touches to this problem. we find that current, like those base models, for example, like Qwen 2.5 3B instruct, is kind of already showing this kind of trend that it cannot learn from failure. But we find that those models trained with RL even become worse at that. So like if you let them try 5 times versus if you let them try 1 time, the improvement is very, very little. So we might need a new algorithm to make these models really learn from failures. And so this is how we get a closed loop of self-improvement.
So basically humans are really good at RLing themselves, right? Like if you go and you maybe walk but down the street too close to the road, and then like a car almost hits you, you walk further away from the road. You don't need that many experiences, you know, you don't need trillions of tokens from the internet to learn that lesson. So like, do you think this is the issue with transformer, or do you think like it could be solved on top?
Yeah, it's kind of an ability that current models are lack of, but I feel that transformer itself with some techniques could solve it. Like we obviously can embrace better architectures if they are really better. For example, we shift from dense models to these MOE models, and we shift from like linear models to attention, and maybe we are going a little bit back to linear models at this stage, right? Many people are like researching into this. And we might even shift from natural language reasoning to latent reasoning. So these are all very good new like kind of method that we can try. If they finally work out to be better, we can absolutely adapt to it. But I feel that transformer itself is is allowed to be capable in many tasks. I think there are some people showing that theoretically transformer can solve like Turing complete tasks. I forget about the specific paper name, but I just remember the key idea is that transformer can really solve many things theoretically. So I feel that this is something that we can improve with the transformer for now, and it does not need to be bottlenecked by its architecture. But I do feel that the self-improvement capability is a really important capability for us to understand like whether this kind of agents are good for now and whether they can be improved. So the kind of self-improvement loop here, actually, I think it allows us to dig many abilities that is not very well prepared or very well studied right now. One thing I could think is a word modeling capability. So my advisor, Manling, actually works a lot of papers on word modeling capability. So a one sentence definition is that when language model transition from the single-term model to an agent that interacts with the environment, it must know like what kind of things will happen after they take an action. So for example, if I push the table, it will move. If I push the bottle, it will fall. Yeah. So when we are in the single-turn agent, for example, like they kind of answer the mathematical task, or they like do this kind of tool retrieval, I think we can let it remember what will happen from the training stage. For example, if we do this kind of tool-related multi-turn, we can just let the model remember what kind of things will happen after they use a tool. But if we really make them work in an environment, they will keep encountering new environments. Like I think, so my advisors, postdoc, mentor, Feifei and Jiajun from Stanford are working on the kind of like a behavior challenge, which means that they let some agents work on like thousands of environments, and they are all like a simulated household environments. And each time the agent like encounter a new environment, it must know what their environment is like, what their the whole house is like they need to traverse into the house and know like how many rooms are there and what they need to do here. And we have done lots of follow-up work on this. For example, like theory of space, where we change from the current QA style benchmark to some kind of benchmark that the model must travel inside the environment first and stop when they feel that the exploration is already sufficient. And then we give them the questions. So by doing that, we make sure that if the agent is good here, it must know whether it's know this environment or not. So we kind of want to do more on improving the modeling, like word modeling capabilities of these agents, so that when they are really deployed in our environment, it can keep learning from the environment, like what will happen if I do this. And this will like I think work as a very core ability of agents if we really want them to improve in the real world environment.
Yeah, so rather than just text, like, was this a good answer, bad answer? It's like, what state did the room end up in, or this code base end up in, so that they have a better understanding of all the variables and everything at play.
Yeah. Not only about the embodiment of word, but also code and the internet, anything. Yeah.
So is it fair to say that you expect that if we solve the memory issue, there will be fast takeoff?
I think we need to solve all these problems that I mentioned, like memory issue, self-improvement issue, self-improvement core abilities like word modeling.
Okay. So what's your current, like, because it's very hard to make a good benchmark, right? Like they get saturated very fast, and then some companies do like specific training to specific benchmarks. So what do you think makes a good benchmark, and what's your biggest issue with the current benchmarks and evals?
Yeah. So that's a very good question. So I have also been feeling that benchmark saturates a lot because actually I think Gemini 3 Pro uses one of our labs work like MindCube. So it's also about like a spatial intelligence benchmark, and it really improved. I think I don't remember the specific number, but it's large improvement. So I kind of feel that the problem should be non-trivial. So I actually heard from a very prestigious researcher in this field that her taste regarding benchmark problem is that it should be as hard as possible, and you must find a baseline that is non-trivial. So what is kind of a non-trivial baseline? If current model can already do very well on this, then it's not non-trivial. If the best human can do this, it's actually also a little bit non-trivial. So if there's something that even the best human cannot do this very well,
like 10%,
it's considered.
Yeah.
So this is the ideal case, but many realistic case is that not to say the best human, even the best model cannot do this very well. For example, we find actually a very important capability that has been ignored is that agent follows the budget requirement when they execute a task. We probably heard a lot of news that this kind of code agents, you let them work inside your computer, your folder, and they spend like billions of tokens a whole night.
Yeah.
So we tested that like this could not be because of the users did not tell them not to use too much tokens. But even if you tell them, okay, you should use this you should finish this task with like 1 million token, they will use far more than that. And if you ask them to understand, like if you ask them to estimate how many tokens they needed to finish this task, their prediction with the real task finish like token requirement has a very weak correlation. I think it's 0.1 or similar. Yeah.
I think this is similar like when you talk to the models, they're like, okay, this feature could take us a couple months to implement, right? Like they have no idea like what's now possible with how fast things can be built. And I think this is a similar issue here with the cost.
Yeah.
So like, okay, what would a benchmark like that look like? It's like, okay, you want it to land as close to the cost that you say, and then probably the best result to, for that cost.
Yeah. So on my end, I feel that a good benchmark should have this kind of features. So first, I think not only like non-trivial problem that's mentioned, and the second thing is that you kind of have a good understanding presented by your taxonomy that when a model fails, you want to know why it fails. So some benchmark use these successful numbers, but on those fail cases, what's happening, we're not knowing that much. So if there's a good benchmark, I think actually a very easy thing to do is that you not only have a large benchmark, but inside the benchmark, you have different classes. Like, for example, you do spatial intelligence. You give them different tasks for them to do, like allocentric, egocentric, something like active, even more. And you know when agent fails, which subcategory it is doing not that much well. So this is the first thing we can do. The second thing we can do is that to understand not only from the task cases, but from the failure cases in their answer. For example, like some of the models, when they're resolving spatial intelligence problems, they may count the objects wrongly, or they may judge the relationships between different objects wrongly. And there are even more cases. So the final but most important critical thing that we are currently researching on is to understand the failure case of reasoning, which is even much harder than understanding the previous two things, like the prompt or the answer. Because reasoning is something that you even cannot supervise, right? Like you have a lot of proxies to supervise reasoning. For example, you can like check what kind of strategy to use. You can regularize the reasoning into a specific format so you can check more easily. But that's still harder than checking their answers directly. So if a benchmark can do something that can even check models' reasoning, whether they are wrong or not, I think that's pretty much good for the insights to improve these models.
Oh, this is also like how humans, teach it. Like if you're in math class, right, and you have the incorrect result, it's not like the teacher says like, oh yeah, you failed by. It's like, okay, let's look at the steps. And like, okay, step 4 is where you made the mistake. And like, that's how he trains you. It's like focuses on that step, and then you understand that. It's not just like the end, right? So like that would be very like reductionist. And okay, you touched on this reasoning collapse, right? This is, I think, your flagship discovery. So where agents stop thinking. Explain this in simple terms.
Yeah. So during the last year, we've been experiencing RL collapse in lots of our experiments. A very interesting observation is that we find all these single turn tasks, agent will increase its reasoning length all over the training steps. But on multi-turn agentic tasks, at least on the about 20 environments that we tried, all the agents will have a decreased reasoning length all over the steps. It's very strange to us that why these agents cannot learning to reason with RL in these multi-turn agentic steps. And we hypothesize that this might be because the task itself is more difficult. The reward signal is more sparse because when you fail, you don't know which steps you fail. And also the environments we are using is not that much diverse. So agent cannot learn from each of these environments, and they somehow benefit from each other. And we kind of looked into the detailed reasoning of these models, and we show kind of how reasoning collapse happens. So one very commonly used kind of schema is to track the entropy. So if the entropy fails, then the model starts to generate more deterministic reasoning. Like when you give them a prompt, they will generate very deterministic answers. But we kind of use a lot of strategies to make the entropy larger, but the model still cannot get very good performance. And what we find with this model is like although they have very good, like a very high entropy, for example, given the same problem, it can generate different answers. But we find that given all these problems, it will generate a same set of reasoning set. So what this reasoning looks like, for example, given a problem, it will say, that's a good question. It will say, I will finish the task carefully. And it will say like, okay, I'm an agent. I need to do this task. So you can see that entropy is really improving because for all these problems, they will generate diverse answers. But for different problems, it will generate the same set of answers. So we kind of measure it with the mutual information, which means that given the reasoning chain, whether I can detect which prompt it was from. So for example, if there's a reasoning chain that can be appended to any prompt, we feel that this is kind of more like a template rather than a real input grounded reasoning.
Yeah, it's not from first principles. It's just, I mean, this is probably the reason why like LLMs are bad at inventing new ideas, It's like if different things can lead them through the same reasoning chain, then, I mean, humans are probably just more diverse in this. As you said, like higher entropy.
Yeah. So we kind of detected this problem and understood one of the root causes is because the noise, noise that is hard to prohibit from this RL stage for these models. All this task itself have noise, and we are even keep adding noise to these models. For example, we have the entropy bonus, we have the KL term, which is actually irrelevant to the task. And all this noise come together to make the model, like when they generate kind of a response that is very safe and can get this kind of baseline reward, it will stick to it because it does not know what, like if they try other things, they will encounter this noise and okay, they were they will kind of prohibit themselves from generating new things, but rather stay in a safe area for
Comfort
this
zone,
reason.
basically, for the model.
Yeah.
Interesting.
Yeah.
But isn't that like
So,
kind of implied by the autoregressive architecture that they're gonna do this?
So it's not exactly about architecture because finally we find that the noise from the task itself is higher than we expected. So we kind of measured the gradients from all these models, like when they are doing RL update, and we find that even for this task with very low reward variance, which means that the model generates a lot of answers and a trajectory and find that their reward is very similar to each other. We find that even for these groups, RL will still make them a lot of gradients, which means that like RL itself feels like there's a lot of things you learn inside the trajectories, even if they appear to be similar. And we feel this is where the noise come from, because actually for this prompt, you just mute yourself from it, because these are the problems that I generate. Like when I think about them for a lot of times, I get the same reward. So the best strategy is just to mute it, because this is not worth learning, either because it is too easy or too hard. But actually the current RL algorithm feels like they actually make the very large grand norm here. So the model keeps learning themselves from this kind of very unworthy to learn instances. And our intervention is very simple, just to remove it. And remove the model from those low signal to noise ratio trajectories, and keep the model learning on this tasks that are worth learning at its RL moment. So it's kind of like you yourself as a human, you experience a lot, and something is just forgotten. You feel that is not worth your learning, and you don't learn it.
Maybe like a bad book, like you just stop reading if you're not.
Yeah. You just stop learning it. And we find this is the same for RL. And what's more even surprising is that we actually improve the efficiency of these models, because some people may say that, okay, you generate a lot of rollout and you drop a lot of them, so the efficiency is very bad. But actually we find that if you are not learning from these bad trajectories, you actually prevent yourself from these noises. So you actually learn faster because you are only learning on those trajectories that are worth learning.
This is very interesting. What is for people who are not researchers, what does elite AI research look like? Is it more like exploration, you have intuition, you go play around with it? Or is it more like strict, scientific approach? Like day to day, practically, how does it look like?
Yeah, so to me, doing research is you have an idea, and the idea is kind of that you believe something, and you're not sure whether your belief is correct or not, and you try to verify it. So for all the AI research, it's like you have a belief that models should be trained in several ways. And for example, data should be formulated like this, or something of the model, some bottleneck of the model is not clearly researched, and you kind of want to build your work upon that. For example, you take research into related works and see if they have already taken research into this matter, and you somehow train all these models on this either small scale or large scale. But the final goal is that you want to make sure that your assumption is right, and it can persuade others at the same field. Yeah.
So the very most important prerequisite is basically being good at questioning things, right? Don't just assume that this is the way the field does it, doing it this way. What came to mind is the early days of OpenAI when they discovered the scaling laws, and everybody assumed that more data is bad because it's going to be overfitting and other issues, and they were what if more data is good? And they tried it, and the model was better. They tried it again, the model was that much better, and that was a huge discovery that is powering the AI race right now. So I guess it's how would you describe it? A combination of raw intelligence with questioning society or conventions. What are some other variables that make a great researcher?
Yeah. So regarding the questionability itself, I think it's becoming more and more important, especially if you are doing research, because all these agents can verify the answer for you very well. So the taste and the ability to raise important questions are becoming more and more important. So it's kind of not I think this leads to another important ability that I would like to say is you don't only ask an important but obvious question. You can decompose it to plans and make concrete steps. For example, we know that like self-involving agent is important, but what are the specific things, the specific question you can ask based on the current progress of yourself, of the society? So, like my friend talked to me a lot about they feel kind of like this neuroscience is becoming more important because like a human can just upload their awareness to a computer and something like that. But I think this is really important, but how can we achieve that from now? What is the thing that we can do at now? So so this actually like troubles them a lot. But I feel this is the core ability. If you want to do research, you have to know what you can do right now.
Yeah, that's true. Like timing and what's possible, having a good intuition there. It's like, Google Glass is the famous example for like 2012 or something, the AR glasses, and it's just too early for that technology. And throughout history, there was many instances, like the AI field is a whole thing. People are in the 50s are predicting like we're a couple of weeks away, from AGI basically, and they were just too early. So yeah, like knowing, this is probably the hardest part, is like knowing what's possible and having a good like intuition of like, this is still years away and this is possible now. Because, you can be a genius with like idea from the future, but then you're like kind of wasting your time because you're just working on something that simply isn't possible given our current tools and current technology.
Yeah.
That's fascinating. Yeah. Do you think the current like coding tools could like be truly called agents? Like, because a lot of people don't really understand the difference between LLM and an agent. So how would you describe that? What is like a true agent?
Oh, this is a very big question, I think. So I think there are a lot of definitions around for what is actually an agent. But I think the biggest different thing from the agent is the environment. It's not the agent, it's the environment.
Yeah.
So we can probably hear from a lot of people working on this RL field that the agent can only learn what is already embedded in their knowledge. And we can take a look at what kind of tasks they use. I think it's quite normal, and I think their work is quite good based on their own findings on these tasks. But it's like math, singleton coding, question answering. And you kind of feel that they can only get feedback from their own answers. They cannot get feedback from the world.
Again, like human analogy is helpful here because like, human is obviously people compare it to like agent, like AGI is capable of what intelligent human can do. But if you take an intelligent human, you put him in solitary confinement and prison, and you only let him write like one letter per month on a piece of paper, and like there is no other input from that human, then like people wouldn't say that's AGI. Because like it's only outputting text tokens, but in fact it is AGI, it's just limited by the environment.
Yeah, completely agree. Yeah, I think exactly this is what I feel that a real agent needs to be inside an environment. Even LM is inside an environment, actually is an agent, but not that much good agent. We need to train that to let it.
Maybe like OpenClaw is a step in that direction, like people realizing like if you give an AI full dedicated computer and you just don't limit it, you don't have to like press enter for permissions, suddenly the same model is way more powerful.
Yeah, of course. OpenClaw is like definitely an agent. And the next step is how can we make self-improving agents?
So basically like removing the roadblocks, like starting with online, obviously, because software moves faster than hardware, but then going physical humanoid robots. So like basically like listing out the things, that those are probably like amazing startup opportunities. Listing out the things that like agents cannot do efficiently right now on the web that humans can, and they're just like destroying them, right? Like payments, authentication, stuff like that.
Yeah.
That's probably like where a lot of progress will be unlocked.
Yeah. I think first thing is low latency decision making. So I've tried a lot of web agents because I interned at Utori, like the web agent company, last year in the summer. So we get a research into all these kind of web agents around the world and find that they can do good reasoning for each step. For example, which button they need to click at each stage. Yeah, it's very slow, and it's not something acceptable for human to think a lot before they really take an action. So one ability. Another is I kind of feel, I'm not sure what specifically the thing is like, but actually I kind of feel that all these agents, web agents, currently they cannot even click a button very well. So yeah, kind of strange, but it's true that they have good reasoning, but they don't know how to ground their reasoning to actions.
They don't really understand like they see the button in the DOM or like visually, but they don't understand like the button as a concept probably.
Yeah. First is they don't understand what function the button should have. The other is that they want to click the button, but they fail. They will say that I need to click the button at which position of the web page, but actually the position is very wrong. And it's kind of strange that even with the SFT and RL, it's very hard to improve it. Yeah, so I feel there's something inside the multimodal infra or like multimodal architecture that limits us from this. But I'm not an expert in multimodality, so yeah, just a guess. And
anything else that comes to mind that's limiting?
Word modeling, budget awareness, as I mentioned, and let me think about something more. I can only think about this, but
yeah, I mean these would already be huge, you know. Like if all of these were solved, which are probably closer than we think, then even with zero improvement in the models, it would already be like massive gains, right? Like we see many of these like services like Rent a Human and like other creative stuff where so there was this Web4 thing where agent can pay for compute with crypto and like he has to make money to survive. Like people are inventing this in real time, and again, like I think a lot of people don't realize what's going to be possible very soon.
Yeah.
Do you feel that way? That like we're like living through, just some, whether it's slow takeoff, fast takeoff, but like living through like a pivotal moment?
Yeah. My a little bit unique take on this is like I've been hearing about this word from my primary school state. So every year is pivotal. So I don't know which year is more pivotal than other years. So my take on this is like if you feel you're living in the pivotal age, like just remember or just think about like whichever year is pretty pivotal, and the only thing that you can do is to think about how to live yourself in this pivotal age. So
how to get involved, how to participate.
I think just enjoy it. So don't be afraid of like being taken away or like have this kind of formal stuff. So I kind of believe that at the end of the day, everyone will not need to work because their working efficiency is much like lower than AI right now. So if human can still have some kind of strength over AI, then we can use it to improve AI. If human is kind of useless in improving the society, then we can just handle to AI. And so yeah, there is a kind of a thought on this. It's like if you make sure that your AI is capable and also they help humans. So it's kind of not like you build an AI and they decided not to take humans as kind of the world and they kind of want to eliminate humans, but it's like you improve the models, and before you make to the final stage of AGI, you first make sure that they are aligned and they will not hurt human. And then we can even let the human think, even let the AI think how to improve humans from both the society, from the education, from how we do things, from how we think what we are philosophically. So if we have a strong enough AI, it will figure out how to make us human become better. Yeah, and I think this is the meaning of why we are like working on this AI field.
Awesome, man. I think that's a great place to end it.
Yeah.
Thank you very much for the time. Where should people go to check out more of your work? Or Twitter?
So there's a link, zenus.me, and you can check my work and our lab and all the things that I post, like those Twitter polls, some thoughts, some academia translations, and so much more. Yeah.